Assalamualaikum warahmatullahi wabarakatuh. Please let me introduce myself. My name is Muhammad Jati Nugroho, and I would like to thanks to ICIMECE 2020 and PJB Connect because the opportunity that give us to present our paper root cause analysis of fire in coal power plant using Rfmea method. And the author of this paper are myself, Muhammad Jati Nugroho, Egga Bahartyan, Rifky Raymond, Budi, Hidayat, and Mr. Muhammad Irawan. And for the outline, we have four. And first is about introduction. We explain about background and objective. The second is about method Rfmea. The result is discussion about risk failure mode effect analysis and alternative solution. And the last is about conclusion. It's about conclusion and recommendation. For introduction, as we know that many of power plant with use lowering coal. This is the lowering coal. When the lowering coal is dusty and equipment damage and accumulation of coal dust that has not been cleared with candidates of self-combustion or fire. And risk management as a comprehensive risk management system. And the third is about there has been 192 incidents of self-combustion or fire that occurred during the period of 2018 April until April 2020 at PJB Pacitan. And PJB Pacitan is currently not doing any risk mapping for coal handling equipment operation in power plant. For the method, the Rfmea has similar with FMEA, only the additional is about risk con. The FMEA and Rfmea model system, we can explain that the first step is a detect a risk mode. This is for FMEA method. And then the second is separate, we calculate separate numbers. And the third is probability number. The step 4, we calculate detection number. And the last is calculate the risk priority number that multiply of the severity, occurrence, and detection. And when we use the risk failure mode effect analysis, we need the level of risk that will cut the RPN on the graphic of scatter plot. And for the methodology, we have 7. The first is about literature study. The second is identification of problem and research. The third is risk identification. The 4 is rating, severity, occurrence, and detection. The 5 is RPM analysis and risk level. The 6th step is about the mitigation plan, and the last is conclusion and recommendation. The result and discussion that we have a history of self-combustion at Pacitan Power Plant on period 2018 until April 2020. That we found that coal yard, it's the highest occurred about 49 accident, and the belt conveyor is about 39 and 35 at mill, and the Carnot boiler is 29 occur. So based this history, we make a type of failure, and we found 15 failure. This 15 failure is we can get from the questionnaire and brainstorming from expert power plant worker with deep interview and questionnaire. We give the worker questionnaire to fill the occurrence, severity, and detection. So after they fill the questionnaire, we can calculate the risk score. With this risk score is a multiply of occurrence and severity, and the RPN, risk priority number, is the multiply of occurrence, severity, and detection. So after the risk score and RPN value we obtain, so we can define the rank and the risk level of a failure. With this RPN ranking, this graphic, we can find the RPN critical value with from total RPN divided by total risk, and the total risk failure about 286.02 divided by 15, and we have the result of about 19.07, and this is the point. So after define the critical value FMEA, we found 6 failure. So then we calculate with Rfmea critical risk. So from FMEA risk of failure, all the value we make a scatter plot of RPN and risk score. Yeah, we can find this from this risk score and RPN. We make a scatter plot, and we for the RPN we will cut with the level of risk. This is the metric risk standard of PJB that define the level risk from 10 is they indicate that the risk must be treatment first. Yeah. So when we define this scatter plot and make RPN cut with the risk score, we found only one. That's the one is called is Dusty with risk score 11.66, and the RPN is the value is 32.05, and the risk level is high risk. Yeah. So this is about here. The position is about here. So the conclusion, coal dusty is can from the mine and coal dust from coal yard. The risk mitigation coal dust from coal yard, we have to. The coal transportation is prioritized using the type of ship because the location of power plant is located in the south of Java, where the sea waves are very strong, and mining locations are on the island of Borneo and on the island of Sumatra, resulting in long coal shipping trips. When using bulk, fast delivery duration can prevent coal deformation with cause dust. Grab ship unloading has been equipped by a nozzle as dust controller with a defined pressure. Efficiency is increased when the nozzle is very small to produce smoother mist. Soft fog is more effective in dropping small dust particles from the air. Likewise, modifying a small nozzle can produce more effective mist in controlling dust during the demolition process. And for risk mitigation dust from coal yard, we have 5. The first is the implementation of FIFO, first in, first out, because this method can prevent coal deformation, which can cause dust and even combustible itself. And during the process of unloading coal from Jati, the coal fill in transfer tower 0 to transfer tower 2, conveyor belt dust sprayer system is installed with mixed with surfactant. So that coal is emulated with a surfactant can wind, dust, and protect coal from oxygen contamination, so that during the transfer process, dust contamination on the conveyor become much less and cleaner. And the third is install a water spray fogging jet system for coal wetting in the coal field to maintain coal temperature as stable temperature. And therefore, the process of loading coal from coal field is prioritized using a stacker and then compact with a wheel loader by making a triangular shape from the coal core terrace to avoid the gusts of the wind entering through the cavities of the coal pile. And the last, install the auxiliary water fogging fan when loading is using a wheel loader that can catch flying coal dust. And thank you. This is our presentation about the paper. I hope this paper can benefit you. Thank you.